Hello, everyone. This is the Prophet Michael David, aka Aries, and happy Michaelmas again for the second time today. And this is my second video, and I'm wearing the special tie, so you're welcome. So, today's video is about how I solved the Riemann hypothesis. Okay, as always, that is the video that you should watch before you watch this video. And the other one, yeah, format, yeah, all the stuff in that folder is what I use to make this video. I'm being consistent over the last 4 videos. Okay, so stay with me. This is going to get real nerdy real fast, at least at the start and everything. But this is how, like, modern mathematicians have tried to attack this equation. So look at these screenshots and then I will explain them as concisely as I can. Okay, after staring at those screenshots, if you're interested in this type of stuff, which you should be, or you should do if you're interested in this type of stuff. Um, so basically, what Riemann did is he took the sigma function, which couldn't be divided, which was undefined under zero. And basically, what it is, he flipped it over, and they're like, okay, if we want to make this look identical, what kind of equation do we have to make it look identical? In this whole, it's called a gamma function world, gamma function universe. And so they did that, and then that's the second screenshot. They came up with this functional equation where it's plug and play. So like you just pick a value and you're like, okay, it's whatever value. But if you happen to pick it on this half line, and that was his hypothesis, was that all these zeros had to lie on the half line. You type in, 1/2 for the real part of the equation, and then you try to find out when it hits zero. And it's just plug and play, under zero, under zero, under zero, over zero, pick a number smaller, 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 smaller. That's why they call it transcendental. But that is why how all modern mathematicians have tried to attack this equation, right? That strip, they have proven somehow that all of them are in that strip. And Littlewood and Hardy proved that there are an infinite amount of them, and they all seem to come on this exact half line. They've done, you've seen the video, they've done millions, billions, trillions, and they all end up on the half line, but they can't prove it because it's plug and play equation that just tells you what the outcome is. It has no predictive aspect. And so as a geometer and a mathematician, if you're ever going to solve this equation, insanity is doing the same thing over and over and expecting different results. If you can't prove this or disprove this in the way they're doing with supercomputers, you have to find a different angle to prove it. Just like I told you guys with perfect numbers. I turned something that was all about large numbers, really, really large numbers, into something that was just a geometrical summation, which is kind of what the Riemann hypothesis as well. Okay, before we start on the solution, like a little sidebar here was those two slides back in the day when I was trying to actually work with the zeta zeros and everything, because you can find them on the internet. But man, I tried all my dirty dick geometer tricks on it, and I could never. I always came up with graphs like the second screenshot, just pure. It's just noise and everything. Somehow you can add them all up to be the prime numbers and everything, but like trying for so long, I tried to find order out of pure chaos, and like even I can't do that shit. So Again, like insanity. Try the same thing over and over and never works. Why try it again? But I did. Even I did that. So, but eventually, and you guys will realize why I needed to solve the first three first. I found a different way to solve it, which I did. So here we go. For you who've actually watched the videos, you remember that G from the college conjecture video. That man's name is Jeffrey Ligarius, and he is a very famous mathematician. Again, if you've seen the video, but I decided, because he was working on colloids, and not that many people work on colloids because it's notorious nature. I decided to look up his wiki. So this is what I found. So I found his wiki, and like it's pretty short because again, but I saw that he worked on the Kautz conjecture and the Riemann hypothesis for a long ass time, and so he didn't publish a lot of stuff, and that's why mathematicians don't attack that type of stuff because it's hard to make papers about, and that's what they're concerned with. But for me, I was like, yeah, okay, like that's I can respect that and everything. And then I clicked on the hyperlink to see his, he basically found another way to prove the Riemann hypothesis using it's related to the other one. You guys can read it. I was like, all right, that's cool too. And then I looked at the third uh, screenshot is the actual thing that he worked upon. And I did work upon his way, but like dealing with harmonics is a lot harder than dealing with natural numbers, especially in spreadsheets, because they cut off the number anyway. So eventually I got to that third one, and I saw Ramanujan worked on it as well. And like I just, something clicked where I was like, that's the way you should try to solve the Riemann hypothesis. Oh, that screenshot is, of course, my pi approximation. I don't know why I'm throwing it in this one, except the creator. This is one of those I'm smarter than you people stuff. Like the guys explained how to solve the Riemann hypothesis, and when he gave you a chance to solve this, you guys didn't even try. So, anyway, here we go about the epiphany on the Riemann hypothesis. So if you read Jeffrey Ligarius's paper, you can see that those are what he calls colossally abundant numbers, which are just the most divisible numbers in the number spectrum, if you want to call it that. They're basically the opposite of primes. And that's what, with the sigma function in the previous equation from the last slide, I realized that the way to prove the Riemann hypothesis true was not to do it with the zeta zeros, but to do it with the colossally abundant numbers. But then I looked at them, I'm like, is that all the colossally abundant numbers? You know, um, or just some of them? And I don't know to this day how Jeffrey Ligarius came up with them, but I came with my own technique, and no, that's not. If you are trying to find going from one to infinity, the next most divisible number there is a way to do that. And I came up with a technique to do that. So I could do a TED talk on this for hours and hours and hours and everything. But if you look at the screenshots, you can see I found that those colossally abundant numbers, the most divisible numbers, I found that there were more of them and they came in a certain sequence and it was related to the prime numbers and everything. And I'm not going to go over it right now and everything because you can look at it. But from there, I collected, using the system, collected all the colossally abundant numbers, the most divisible numbers that I could use for that equation, and then I put in a spreadsheet like this. Okay, I know that looks like a bunch of information to the average mortal, and it is, but for mathematicians, they could see if they really look at it. I just basically set up the equation, and I have a way to sieve the most divisible numbers, and so you can see that it's never going to get anywhere close. So, and then the next slides, I'm just going to show you like the visual graphs that I did to prove this stuff. Again, like to most of you, it might look like a wall of text, but with all the other information that I've given you, to a true mathematician that has any sort of knowledge in the Riemann hypothesis, they would be like very surprised that the Riemann hypothesis is linked to mod lines. So lastly, those are the graphs that I made from, the spreadsheets that I showed you the screenshots earlier that show that when you look at the Riemann hypothesis from, you know, the equation of divisibility, no, it's harmonizing on a single number and everything. So you have more than enough information to see that obviously it is true. So, yeah. Anyway, I love you all. I'm really looking forward to taking off the suit and this tie and everything. I'll talk to you later. I'll probably do one more video about like the whole what I'm doing in the future, you know, running from the law and everything. But for now, I just want to have a couple more beers and smoke a bowl and watch some videos and go to bed. It seems like it's been a long day. So, again, I love you all. Rule number one, do not touch other people without their consent, aka do not hurt each other. And rule number two, it's all about honesty. Lies are a tick down, aka try not to lie. All right, I'll talk to you all later.